Okay, just a short video this time, continuing on with the organic chemistry and the hydrocarbons subtopic, and we're going to look at the combustion of hydrocarbons now. You may well have done a lot of this previously. If you have, that's good. This will be a recap. If not, I'll just go through this stuff so we can quickly get you up to speed. So, strictly speaking, all the SACE board says that you need to be able to do is write equations for the complete combustion of hydrocarbons. I'm going to go into a little bit more detail than that because I think it is important and it prepares you well for stage 2 chemistry. So complete combustion happens when you've got an excess of oxygen. If you want to think about what you've done probably in the lab with the Bunsen burner, when you open up that air hole at the bottom, you get the blue flame, you get lots of oxygen going into the flame, and you get a hotter complete combustion flame. If you've done any oxyacetylene welding, you probably know when you turn on the lighter and you turn on the acetylene, you get that very yellow flame, and then as you bring in the oxygen to the flame, you get that hotter blue flame. So if we have any fuel or any hydrocarbon and we react an excess of oxygen with it, the products of that reaction will be carbon dioxide and water. Now, the hydrocarbon could just be an alkane or an alkene, but if it's got any oxygens in, this reaction still applies. So that's why I've chosen ethanol here as my example, but it would equally apply for methane, propane, butane, any of those fuels as well. We will get exactly the same reaction. So, hydrocarbon plus oxygen will go to CO2 plus water. Let's just quickly also balance that reaction, and you'll also see the purpose of me balancing it in a minute. We have 2 carbons on this side, so we need to put a 2. Oops, that's not the pen that I want. Go undo, you probably won't even see that. Try this. Oops, that's not the colour I want. Take 3. There we go. We get 2 CO2. And now, so you do carbons first when you're balancing, do non-metals other than oxygen and hydrogen. Then you do hydrogen. So we've got 3, 5, 6 hydrogen here. So we need 3 H2 to give 6 hydrogen on this side. And now we finally do oxygen, and we've got 2 2s of 4 plus 3, 7. So we need 7 oxygen this side. So if you go, if we have 3, that would be 6. If we have 4, that'd be 8. Do we go to double everything? Well, when you're balancing oxygen in a combustion equation, it is fine to use a half mole. So that would be 3.5, because 3.5 times 2 is 7. That would give you 7 oxygen. The reason you can do that is what this reaction really indicates is that if you take 1 mole of ethanol and react it with 3.5 moles of oxygen, you will get 2 moles of CO2 and 3 moles of water. So normally we don't have halves when we balance equations, but when we do combustion equations, we tend to. So we're always talking about 1 mole of the hydrocarbon fuel. So that's the process that you can apply for writing an equation for the complete combustion of any hydrocarbon. Now, in incomplete combustion, there's a couple of different things that can happen. If you've just got a limited supply of oxygen, when the hydrocarbon and the oxygen react, you will get carbon monoxide form and water. So, carbon monoxide here, CO, is actually quite a toxic, dangerous gas. Will actually bind to the hemoglobin, which normally carries oxygen, but it will bind instead of oxygen, and then obviously your body won't be able to get oxygen. That's why it's, a very dangerous, potentially deadly gas. So, again though, how do we balance this equation? Well, we've got 2 carbons on this side, so we need 2 carbons here. We have got 3, 5, 6 hydrogen, so we need 3 H2O, and we now have 2 oxygen here. So, hang on, I made a mistake there. That should be 3 H2O. Sorry about that. So still 2 carbon, 2 carbon, 6 hydrogen, 6 hydrogen, and now we have 2 oxygen on this side, 2 oxygen here, +3 for the 3 waters, so there's 5 oxygen there. So now we need 2.5 moles of O2 to give us 5 moles of oxygen atoms. And then finally, if we've got a really limited supply of oxygen, and this is what tends to happen when you've got that air hole closed completely on the Bunsen burner, you'll get a very yellow flame. It'll be a very sooty flame. And then, again, let's balance 2 carbons. So we need a 2 here, 6, so we need 3 water. And now we see 3 oxygen here, so we need 1.5 moles of O2 will give us 3 moles of oxygen. So you can see here, where's my laser pointer? The amount of oxygen that's needed is decreasing. 3.5 moles here, 2.5 moles here, 1.5 moles here. As the amount of oxygen decreases, we go from getting carbon dioxide to carbon monoxide to carbon, which forms as soot. Soot is not as toxic as carbon monoxide, but it's very dirty. It's also a respiratory irritant, so it can affect breathing and that sort of thing as well. But I think that is hopefully all you should need to know about the combustion of hydrocarbons. We will explore in stage 2 chem next year a little bit more about how we work out the energy release from those reactions, but that's for next year. Cheers.